This section examines forced induction. One way to improve engine output is to increase the amount of air-fuel mixture that is burned in the cylinder. That means increasing volumetric efficiency, or how much air is delivered to the engine. This is done by what is called forced induction. Forced induction increases air pressure in the intake manifold above atmospheric pressure. An engine using forced induction can have a volumetric efficiency above 100%. A turbocharger uses energy that's normally wasted through the exhaust. Exhaust gases enter a turbine and make it spin. The more gases, the faster it spins. A shaft connects the turbine to an intake compressor. It compresses the air and forces it under pressure into the intake manifold. The turbine operates at very high temperatures and with the compressor can rotate at well over 100,000 revolutions per minute. So they both need a good supply of clean oil to lubricate their bearings and carry heat away. Some engines also supply coolant to the turbocharger body to improve cooling. On petrol engines, higher and higher engine speeds mean more and more exhaust gases, and that makes the turbocharger force more and more air into the cylinders. This can damage the engine. To control this, a device called a wastegate is fitted to the exhaust inlet of the turbocharger. When air pressure in the intake manifold reaches a preset level, it automatically directs exhaust gases away from the turbocharger. The wastegate can also be computer controlled to reduce intake air pressure in the event of detonation or knocking. An emergency relief valve may also be fitted so that if the wastegate should fail, it can prevent an abnormal rise in manifold pressure. Since the turbocharger uses the energy of the exhaust gases, there is a short delay between when the driver opens the throttle and when maximum power is available. This is turbo lag, and on larger engines, it's quite noticeable. Because a turbocharger recycles heat energy that would otherwise be lost to the engine, it can seem to be offering additional energy for nothing. But a turbocharger can introduce problems of its own. The extra heat and power it generates can put an extra load on the engine's cooling and lubrication systems. This is provided for by the manufacturer. As the air passes through the turbocharger, it heats up. But hot air is less dense than cool air, so it tries to expand again, and some of the benefits of compressing it are lost. To stop this and improve efficiency, some engines use an intercooler to cool the compressed air. It fits between the turbocharger and the engine. It's usually air-cooled.